The universe feels unbelievably big. Galaxies stretch across enormous distances. Light takes billions of years to reach us. And the more we look, the bigger everything seems to get. That naturally leads to a simple question. Why is the universe so big? Was it designed to be this way? Or did it have to become this large? The surprising answer is that the universe isn't big in the way we usually imagine. And once we understand what big really means, the question becomes much simpler. When we think about size, we usually think in terms of space. How far something stretches from one side to another. But when it comes to the universe, size is closely tied to time. The universe is about 13.8 billion years old. That means light has only had 13.8 billion years to travel. So when we look out into space, we're not just seeing distant objects. We're seeing old light. The farther away something is, the further back in time we're looking. This leads to an important idea. The size of the universe we can observe is limited not by space itself, but by how long the universe has existed. There is also an important distinction most people don't realize. The observable universe is not the same as the entire universe. The observable universe is simply the part of the universe whose light has had time to reach us. Beyond that, there may be much more universe. We just cannot see it because its light hasn't arrived yet. This doesn't mean there's an edge or a boundary. It means there's a cosmic horizon set by time and the speed of light. So when we say the universe is big, what we usually mean is that the observable universe is very large, and that size is directly connected to the universe's age. Our intuition about size comes from everyday experience. When we think about something being big, we imagine it sitting inside a larger space. A room is big because it takes up more space than a small room. A city is big because it spreads out over a large area. But the universe does not sit inside anything. There is no larger container around it. This is where our intuition breaks down. When we imagine the universe expanding, we often picture matter flying outward into empty space. But that is not what expansion means. Expansion means that the distances between points in space are increasing everywhere at once. Space itself is stretching. Because we never experience space stretching in daily life, our brains try to replace it with something familiar. We imagine edges. We imagine centers. We imagine boundaries. But those ideas come from objects inside space, not from space itself. On cosmic scales, big does not mean wide in the usual sense. It means old. It means expanded. And it means limited by how long light has had to travel. Once we let go of the idea that the universe is an object inside something else, its enormous size starts to make sense. Another common misunderstanding is how the universe became so large. The Big Bang was not an explosion that sent matter flying outward into empty space. Instead, space itself has been expanding. Every region of space is stretching, carrying galaxies along with it. The universe did not start small and expand into something else. It started hot and dense, and space itself grew larger over time. Because the universe has been expanding for billions of years, the distances between galaxies have grown enormously. So the universe appears big today not because it began that way, but because it has had a very long time to expand. Here's the key idea. The universe isn't big because it needed to be. It's big because it is old, and expansion takes time. If the universe were younger, the observable universe would be smaller. If light could travel infinitely fast, we would see much farther. But because light has a finite speed, and the universe has a finite age, there is a natural limit to what we can observe. In other words, the universe looks big because we are looking across billions of years of cosmic history. So why is the universe so big? Because the universe is old, and space has been expanding for billions of years. What we call the size of the universe is really the distance light has been able to travel since the universe began. There's no known edge we are approaching. There's no center we are moving away from. The universe doesn't appear large because it was meant to be. It appears large because time has passed, space has stretched, and light has had a finite amount of time to reach us. Once we understand that, the vast scale of the universe stops feeling mysterious. It becomes a natural consequence of age, motion, and the structure of space itself.